what situations should division be replaced by multiplication, or should subtraction be replaced by addition. So I have a couple of examples over here on the right-hand side, most of which are drawn from arithmetic, but some of them are drawn from algebra as well. And hopefully we'll use these examples to see, maybe when and hopefully why it's a good idea to make such replacements. So just as a reminder, how do you replace subtraction with addition? Or how do you replace division with multiplication? We can do these things because these are inverse operations to one another. Division is nothing more than multiplication by a reciprocal. In other words, flip the fraction upside down. Instead of dividing by it, you can then multiply by it. Likewise, subtraction is nothing more than addition of the opposite. So instead of subtracting a number, we can just add the opposite, the additive inverse of that number. By the way, there's another one for the top layer of the arithmetic layer cake over here that we've seen elsewhere in our course. A root is nothing more than an exponent of a denominator, which is kind of a clumsy way of saying things. But we can also trade roots for powers instead. The same way that we can trade division for multiplication, and the same way we can trade subtraction for addition. So let's just go through a few examples of what these substitutions look like, and maybe a guiding principle will come out of this. So our first example where I'm thinking about division is the example where I just want to know, what is 35 divided by 5? Another way to write that division problem would just be to write it as the fraction, 35 over 5. And we happen to know, just because we know our multiplication tables, what the answer to that division problem is. It's 7. So I don't think there's any value in trading out the division for multiplication in an example that's that straightforward. So I would say probably don't substitute. Don't trade division for multiplication in that example, because it's not really likely to help. But that's really the only case in which I'm going to say that it doesn't pay to trade division for multiplication. As soon as I go to the next example, 16 divided by 1/2, already this is an example that doesn't make much sense to us as a division problem. We could cook up some weird sort of contextual examples for what this would be like, right? Let's suppose that I have 16 pizzas or something like that, and I want to distribute half of the pizza to everybody in a room. How many people in that room are going to get pizza? Well, if I have 16 pizzas and everybody's getting half a pizza, that means I can feed 32 people, right? Twice as many people as pizzas. So that's kind of a contrived example of how to do this division problem as a division problem. But rather than get contextual every time we see a problem like this, from an arithmetic standpoint, this is probably the first example where it would be beneficial to trade division for multiplication. And we can trade division for multiplication if we take the reciprocal of the divisor. The divisor here is 1/2. If we replace that by its reciprocal 2 over 1, then we also succeed in replacing division by multiplication. And we then get the multiplication problem 16 times 2 over 1. 2 over 1 is otherwise known as 2, so I have 16 times 2. And so as soon as we start doing arithmetic with fractions, particularly with fractions that are our divisors, the second part of a division problem, that's already a situation where we should start thinking about replacing division by multiplication by replacing that divisor by its reciprocal. Already that helps us to make sense. It gives us a clearer path to the solution of this problem. The same goes in the next example, 3/8 divided by 3/4. Again, we have the divisor here as a fraction. And so replacing that divisor by its reciprocal is going to give us, instead of a division problem, a multiplication problem. Here the dividend also happens to be a fraction, which means that the only way to do this problem is to implement the multiplication strategy for fractions, which says multiply straight across. 3 times 4 is going to give me 12. 8 times 3 is 24. And then simplify the result. 12 over 24, if we reduce by factors of 12, gives us 1/2. So again, in a situation like that, I recommend, yes, replace division by multiplication whenever the divisor is itself a fraction. The same goes in an algebra sense If I'm going to divide these two rational expressions by one another, 2 over x minus 1 divided by 3 over x squared minus 1, I can't divide fractions. I'm just not going to do it. I'm not going to even try to get my head around dividing fractions without turning it from a division problem into a multiplication problem instead. And so what I really have is 2 over x minus 1 times x squared minus 1 over 3. And then to multiply, we'll just multiply straight across. That's going to give me 2 times x squared minus 1 divided by x minus 1 quantity times 3, which I can simplify by factoring the numerator. I'm going to clear a little more space for myself here. My numerator is going to be, if I factor it, x plus 1 times x minus 1. And I have that 2 out in the front. My denominator is x minus 1 times 3. I had to factor that numerator because it's the only way that I could see that I have a factor that cancels, an x minus 1 that cancels. And so I'm going to end up with 2 times x plus 1 divided by 3. Again, I would not recommend trying to do any fraction division problem, or for that matter, a rational expression division problem, without instead changing the division to a multiplication. So the only case in which I would not recommend replacing division by multiplication is if both your divisor and your dividend are just whole numbers, right? Because those are just the answers to sort of, let's call them elementary arithmetic division problems that are just solved with your times tables, essentially. But anything that's more complicated than that, as soon as there are fractions of any kind in the picture, it's a good idea to replace division by multiplication by the reciprocal. It's a similar story for replacing subtraction with addition. The problem at the top here, 12 minus 8, well, again, that's a basic subtraction problem that doesn't really need a substitution. It doesn't really help us to replace that subtraction with addition instead. But as soon as we move to a more complicated example where the second of my terms here, my subtrahend, the negative 10 in the next example, 12 minus negative 10, as soon as that is negative, as soon as I'm subtracting a negative quantity, that's probably a case when I want to replace subtraction with addition instead, and replace that subtrahend by its additive inverse. 12 plus positive 10. 2 minuses make a plus. So 22. And I do want to substitute there. Same thing for the next example, negative 16 minus negative 12 is the same as negative 16 plus 12. It's negative 4. And then for our last example, 3x minus 1 minus the quantity x plus 2. What I recommend doing here is replacing that with plus the opposite of x plus 2. And the opposite of x plus 2 is the same thing as x plus 2 multiplied by negative 1. That's useful because then we know we need to distribute that negative 1 across both of the terms in the parentheses. Plus minus x, plus minus 2. And there I get my answer. So maybe my broad answer to this question, when should we replace division by multiplication or subtraction by addition, is almost always. In particular, the times when it is almost necessary to do so is when the second quantity in your problem, the divisor in the case of a division problem, or the subtrahend in the example of a subtraction problem, when that quantity is complicated, when it's a fraction in a division problem, or when it's a negative quantity in a subtraction problem, then I'm always going to make that replacement because it's the only way that I can make sense of how to divide or subtract respectively.